Hello everyone. Here on this part we have estimating a population proportion. Okay, what we have here on this part is point estimate, and this is the definition for this part. Point estimate is the value of statistic that estimates the value of parameter. So to find that, we need to use p hat equal to x divided by n. So here x is number of individuals in sample. We have that part here. So x is number of individuals in sample. And n is, we had this one before, so n is sample size. Now example 1. On this example, we have 1,183 registered voters, and so whether they favored or opposed the death penalty for person convicted of murder. And here we have this number, 1,123 were in favor. So what that means, on this part I have n and x, and using these two we can find p hat or point estimate. So based on what we have here on this part, x is 1,123 and sample size is 1,783. Okay, now finding. So we need to find point estimate. So obtain point estimate for the population of registered voters nationwide who are in favor of death penalty, and round the answer to 3 decimal places. So using p hat equal to x divided by n. So x is 1,123 and n is 1,783. Dividing and rounding it, have 0.630. So this is our answer for this part. Then on this part we have so we need to construct and interpret a confidence interval for the population proportion. So population proportion was this one. Okay, let me write that here. So this is population proportion or p hat. Okay, now on this part, construct and interpret a confidence interval for population proportion. What we have here is we have this guess point as the point estimate. So this is estimate of a population parameter. And here we have lower level of confidence, and this one, this interval, is higher level of confidence. So level of confidence is related to width of our interval. So this is the interval we have for lower level, and this is what we have for higher level of confidence. Then on this part is, so this is confidence level, and that is equal to 1 minus alpha. So we call this confidence level or degree of confidence. So what that is, that means the percentage of all possible samples that can be expected to include the true population parameter. So the true population parameter then usually we have this. So for this part, typical value, typical levels that we usually use as 90%, 95%, 99%. So let me write that for here. So typical levels we use, usually I have this one. We have 90%, 95%, and 99%. So based on this, what I have for alpha here, alpha is equal to 10%. Here is 5%, and here is 1%. And how we have that one, because this one and this column, this is 1 minus alpha. So in this column we have 1 minus alpha, and this side we have alpha. So 1 minus 90% is equal to 10%, and that is alpha. Okay. Or vice versa, we have 1 minus this number is 90%, or 1 minus this number is 90%. Okay, now example. On this part, we need to find critical value. And critical value based on what we have here is equal to z alpha divided by 2, and also negative z alpha divided by 2. Okay, so we're going to use these on this part. So I have z alpha divided by 2. So first, finding, so this is given, confidence level is 90%. So using that one, alpha is 10%. Now finding critical value z alpha divided by 2. So here alpha is 10%, and divide by 2. So this is equal to z 5%. And what this one is, this is right tile area. Okay, so adding notes on this bar, z-score. So z-score that corresponds to 0.05 area to the right. So this is what that means. Okay, now I'm trying it to make it more clear what that means here. Okay, so we have this one. If you remember, but we have in between z is 0. Then on left side we have negative z-score, and here is positive on right side. Now what I have here is in confidence level is 90%. So here we have 90%. What that means, on this side we have 5%, and here is 5%. So adding these two, I have 10%, which is equal to alpha. Okay, now for this part, I said that the z-score is right to the so tail area, so right of this part. So I need to find what the answer is for this part. So finding the area to the right. If you remember when we worked on finding area to the right, we need to subtract. So 1 minus area to the left. So what that means, instead of using this one, I need to use what I have here on left. So instead of 5%, now we have 95%. Instead of having what I have on right, I'm using what I have on left. And here on left I have, adding these two, 90% plus 5% is 95%. We can use calculator to find the answer. So I'll use inverse norm, then enter. So this is for 95%. Or using table to find the answer. So here is our table. Here, what I have here, I should have area. So area is in the body of table, I should have 95%. Here I have, okay, here we have 0.9495, and this is 0.9505. What that means, in between we have, so between these two, I have 0.95. Now, based on this area, going to left, we want to find what z-score is. So 1.6 and going up. Here, what I have in between is, so between 4% and 5% is 0.045. So adding these two, I have 1.6, and here is 0.045, so the answer is 1.645. Okay, so we wanted to find what z is on this part, and we use table. And consider when the area is 0.95, so I'm just writing that. We used area to the left. To find z-score. And using table, z was equal to 1.645. So this is the final answer for this part. That is our z. Okay, then next page. Now in this part we have margin of error. So we want to find the difference between point estimate and the true population parameter. So this error is equal to z alpha divided by 2 times square root of p hat times q hat divided by n. We can also write this as times, we have p hat instead of q, 1 minus p hat. So if in case you didn't have q hat, you can use this one to find q hat. Then divided by n. So here, confidence interval for estimating population proportion showing with p, and p hat, what p hat was is sample proportion, and n is number of sample values, e is margin of error on this part, and z alpha divided by 2 is critical value, which was on the previous page. And so what are the requirements for this part? We should have the following steps. We should have simple random sample. To be able to estimate the population proportion. So we should have all these. And the first one is having a simple random sample. In second one, here sample size times sample proportion times. So p hat times q hat. This should be greater than or equal to 10. What that means, this means I should have, okay, at least 5 success and 5 failure. So for this part, n times p greater than or equal to 5, and here n times q greater than or equal to 5. Then number 3 should have independent trials. Remember, we had this one also when using binomial. So for binomial, again, we should have independent trials. Okay, now here is confidence interval. P is, or population proportion, is between sample proportion minus this error, and on this side we have plus. So on left side is minus, and on right side is plus. Now example, determine the point estimate of the population proportion, the margin of error. So we should find point estimate, which is p hat, and margin of error, which is E, and number of individuals in the sample is X. Okay, so now finding all these for the sample size provided lower bound is 0.201, upper bound is 0.249, and sample size is 1,200. But we know that our population proportion should be between, so this is confidence interval, should be between p hat point estimate minus our error and point hat plus error. So on the left side we have lower bound, and here on the right side we have upper bound. Okay, then we should find p hat. So to find p hat, here what I have is the only thing that I have is lower bound and upper bound. I don't have any information about p hat and this error. So how we can find p hat? Okay, so p hat plus e is equal to, so this is upper bound is 0.249 and lower bound as p hat minus error, that is equal to 0.201. Now in this part we have a system of two equations when we need to solve it. How we can solve it? We can cancel this e, because here is positive a, here is negative a. We can cancel this part. So adding these two, on this part p hat plus p hat is 2 p hat. Here is 0 equal to 0.249 plus 0.201 is equal to 0.45 or 0.450. Then divide by 2 both sides. P hat is equal to 0.225. So this is our point estimate. Then we need to find x. Okay, now finding x. To find x, we should use p hat equal to x divided by n. From this part, p hat is 0.225 equal to, finding x, n is 1,200. Now solving for x, multiply by 1,200 to clear this denominator, or you can use cross product. So 1 times x equal to 0.225 times 1,200. So x is equal to 270. So that is our x. Okay, then so we got the answer for p hat, x, and now we should find e. Okay, to find e, I'm using upper limit. You can use lower limit, it doesn't matter. So I'm using upper bound. So that is equal to So this is upper bound. So that is equal to p hat plus error. And for this part, p hat plus error or upper bound, we have 0.249. So 0.249 equal to, and p hat from this part is 0.225. Now solving for this, so subtract 0.225. So E is equal to 0.024. So 0.024 is our margin error. Okay, now next page. Okay, this one we have random sample of 1003. Americans was asked, do you pretty much think televisions are a necessity or luxury you could do without? So of the 1003 adults surveyed, 521 indicated that televisions are a luxury they could do without. So this is our sample, so is N, and here is X. Now part A, obtain a point estimate. So finding point estimate, or p hat. Previous section we had that, okay, this p hat was sample proportion. So the same thing, we only have different words. So point estimate, p hat for the population proportion is p, of adult Americans who believe that televisions are a luxury they could do without. So this part we have luxury. Now the answer is, so p hat equal to x divided by n. X, so 521 believe that is luxury. So, and here also we were asked for that part. So we have luxury. So it's 521 divided by sample is 1003. So the answer is 0.519. Okay, then part B verify that the requirements for construct a confidence interval above P are satisfied. What that means, I should have these requirements. I should have all these three. I should have simple random sample and n times p hat times q hat should be greater than or equal to 10, and I should have independent trials. The requirements for constructing confidence level above p. So these are all for population proportion of p. Okay, starting with the first one. Here I have a random sample. So the first one, I have simple random sample is satisfied. Then second part, I should have n times p hat times q hat. This should be greater than or equal to 10. So this is equal to n is 1003. Okay, let me write this way. So as I said, instead of this percentage, if in case you didn't have any information about q hat, what that means q hat is 1 minus p hat. So that is equal to n times p hat times 1 minus p hat. So now what we have here is n is 1003. P hat is 0.519. And q hat is 1 minus 0.519. So this is p hat. So subtract this part, we have 0.481. Okay, so this is equal to 250.4. This is greater than equal to 10. So it's greater than 10. Now the third one should have independent trials. How we know that we have independent or not? If we had less than 5%, so what that means, if our sample size was less than equal to 5% of population size, then that means this is independent. So 5%, so this is independent. So if this n was less than equal to, so this is what this part means. So n less than equal to 5% of population size. We have, for sure we have this part. Why? Because the population, here we don't have any information about the population, but since we have adult Americans, we can say, yeah, the population is a very large number. So in this case, population size is unknown, but it's a large number. Now part C, we should construct a 95% confidence interval for the population proportion of adult Americans who believe that televisions are a luxury that they could do without. Okay, so finding confidence interval. So for this form, we need to find p hat and e. Okay, so this is a 95% confidence interval. What that means, using that one, alpha is equal to 1 minus 95%. So alpha is equal to 5%. So now we have the alpha divided by 2. So this is our critical value. Alpha is 5% divided by 2. So that is z 0.025. Then using table to find the answer for that part. So first, let me draw this. Okay, so we have 95%. What that means here on left and here on right, we have 0.025. So to find the z, so that the z means I have the area to the right. To find area to the right, instead of right, we should consider the area to the left. So using table, and here I have 0.95 plus 0.025. Now what that means, I have 0.975. Okay, for the area. So finding that area here in the body of table. Okay, that's here. So we have 0.975 going to left. Z is on the side, we have 1.9, and going up we have 0.06. So adding these two numbers, this is Z, so it's 1.96. So the answer for this part is 1.96, and that is critical value. Then we should calculate the E, so based on what I have here, I should find E and P hat. So first finding E. So error is equal to Z, critical value, so Z alpha divided by 2 times here I have P hat times Q hat. Divided by N. So that is equal to, for Z we got 1.96 times N is sample size is 1003. P hat was 0.519 and Q hat was 0.481. So rounding that, the answer is 0.031. So this is our error. Then after that, we can find confidence interval. Okay, so confidence interval, finding that part. We have P hat plus error, that is equal to P hat is 0.519 plus from this part error is 0.031. So that is equal to 0.550. So this was upper bound, now lower bound. P hat minus error is equal to P hat is 0.519 minus 0.031. So that is equal to 0.488. So our interval is 0.488, 0.550. So this is the final answer, this interval. So this one was confidence interval. Okay, now part D. Is it possible that a supermajority, for example, more than 60%, so more than 60% of adult Americans believe that television is a luxury they could do without? So is that possible that is P equal to 0.6 or 60%? Is this one possible? So our confidence interval is p hat minus error, and the side p hat plus error. From previous part, see here, in this part also, they believe that televisions are a luxury. Here we have same thing, televisions is luxury. That's why I can use what I got here for confidence interval. So using what I had in part C, here in part D, for lower bound we got 0.488, and for upper we have 0.550. So using that for here. And then answer this question that can we have this population proportion equal to 60%? See, here I have 55%, and here is 48, 49%. So it's very close to that. So we can answer yes. So it's possible. So that is possible because we are close to 100% confidence. See, on top I have, what is that? Here, part C, I have 95% confidence interval for the population proportion. The answer is yes, it is possible because so we are very close to 100% confidence. So I don't want to write confidence interval, so I'm changing that to confident. So however, then it's asking, is it likely? However, it is unlikely. So the answer for possible was yes, and then part A used the result of part C. So again, we have 95% confidence interval for the population proportion of adult Americans, but in this case, they believe that televisions are necessities, so it's not luxury. So this is the opposite side of what we had in part C. Since that is opposite, we should subtract upper and lower bound from 1 to find new lower bound and new upper bound for this part, because on this part television are necessity. So for lower bound we have 1 minus 0.550, and here for open bond 1 minus 0.488. So the answer is 0.450 and 0.512. You might say, okay, this one on the part C was a lower bound. Why I use that one here? Because if you use this one on top to find lower bound, then the number here would be larger than this one. But the final answer, you should consider, okay, which one is smaller than the other one. The smaller one is lower bound and the larger one is upper bound. So our new interval is population proportion is between 0.450 and 0.512. Or in other words, this one is our interval. So what we have here was that it is necessity, or we can write, okay, this one was, but that means this is not luxury. And that is opposite of part C. Okay, now here again we have this part. So there's P was population proportion, sample proportion, number of sample values, margin of error, and this is critical value. So in this part we need to find the sample size for estimating a population proportion within some specified margin of error. We also have these two. This is based on what we covered already. So if the confidence if the level of confidence increases, that means the margin of error also increases. Also, if sample size increases, margin of error decreases. So why we have that one? So I'm writing what we have for error here again. So error was equal to critical value times P hat Q hat divided by n. See here, if sample size increase, if this one since this one is in denominator, if this one increases, then this error will increase. If this one decrease, since this is in denominator and this one is on top, this will increase. And vice versa. So this one increase, but that means sample size decreases. And same thing for this word, and so level of confidence increases, then the margin of error, so this is again error, increases. If this one increases, we have confidence interval. Okay. So what's this one? See, if this one increases, but that means that you add it to this interval, so this interval will increase. Okay, now let's work on finding sample size. So to find sample size, if you had any information about P, you're going to use this part. If you don't have any information about P, then you need to use this to find N. Okay, so now here on this part we have this example. Okay, let me use P hat on this part. I don't want you make mistake. So example, television sport. Here we have estimate the proportion of Americans who follow professional football. So what sample size should be obtained if you want to be within 3 percentage points with 95% confidence? So sample size, what that is. Now part A, he uses a 2010 estimate of 53%. So we have 53%. What that means, this is point estimate. So it's P hat. We have P hat, so we can use this one to find sample size. So this is point estimate. P hat. We have for 95% of this one here on this part, 95% critical value. So to find that part, we need to find critical value, and okay, to find sample size, we need to have critical value. Okay, so this is equal to Z alpha divided by 2. So alpha is, okay, I'm writing that here. So alpha is 5%. So here we have 5% divided by 2. This is Z 0.025. So instead of having this area to the right, instead using the area to the left, which is 0.975. We had this part before. So finding 0.975 in the body of table, z-score is 1.96. Okay, then finding n. So the sample size is equal to p hat times q hat times critical value divided by error, then square. So that is equal to, our p hat is 53%. Then q hat is 1 minus p hat, which is 0.47%. For z, we got 1.96. And error is here. So this is error. This one, 3%. Then square. Okay, so then rounding that, the answer is 1063.3. What that means, we need the sample size of 1064. So this is the answer for part A. Now part B, he doesn't use any prior estimate on this part. So part B, on part A we had P hat, but then part B we don't have P hat. What that means, instead of using this part to find N, we need to use this. So we don't have any information about P hat, Q hat, and instead we're using 0.25. So Z again is, so this part is repeated, Z is 1.96. And P hat, Q hat is 0.25. This is because we don't have any information about P hat. And E is 3% again. Now finding N. N is 25%. I'm using that one. Then critical value divided by error squaring. On top we have 1.96 divided by error is 3%. Rounding it, the answer is 1067.1. What that means, our sample size here is 1068. Now part C, why are the results from part A and B so close? That is because here P hat Q hat was 0.53 times 0.47. That is equal to 0.2491, which is very close to this part 0.95. So results are close since in part A, P hat Q hat is equal to 0.53 times 0.47, and that is equal to 0.2491, which is very close to 0.25 from part B. Okay, so this is the reason why the results are so close, the sample size. Okay, we finished this part. Bye-bye.